Hey guys, how are you today? Good. Thanks for participating in this session. I think it's going to be very interesting, hopefully, or boring. Let you decide. But I just wanted to talk to you guys about how to build a scalable infrastructure utilizing AWS and Asterisk. And I'm not going to delve into the details on the Asterisk side and configuring SIP trunks and so forth. I'm going to assume that you guys have, or members of your team have experience in connecting SIP trunks between Asterisk machines, whether it's IAX or SIP trunks. So I'd like to focus more on some of the challenges that we encountered and how we were able to address it utilizing AWS. Okay, sounds good? So just a little bit about Finaro. It's a cloud-based contact center platform that utilizes Asterisk in the back end for all of the voice routing and so forth. We started 5 years ago. Prior to Finaro, I led the information technology department at a pretty large contact center based out of Miami for about 10 years. And we've had the fun of working with the Avaya systems and Aspect systems, Five9 in Contact as a customer. Again, as the head of IT at that company, whenever we wanted to open a new center, 300 center location, for example, we'd have to engage the platform that we were using at the time, right? So we were taken to lunches and we were, working with all of these vendors who followed what is pretty common today, which is the software licensing model of paying per agent per seat, whether it's concurrent or not, and support. And I really saw an opportunity to try to do something slightly different in the contact center space, and that's where Finaro came from. It was to create sort of like a Facebook type service, but an enterprise service for contact centers where you can just go online, sign up, and you have the technology that you need to run a contact center instantly. And AWS is really what enabled that. Back in the day, when we needed to configure DS3s and T1s and physical servers, it really held us back from scaling, from my experience. And infrastructure as a service, once it became pretty predominant in our industry, just made things a lot easier, right? We weren't bound physically to a specific location, and it really enabled companies like ours to exist. So again, I just wanted to go through some of the components of AWS that really allowed us to build an infrastructure that could support more than 1 million calls a day on Asterisk. The core components that we utilized was EC2, and that represents the actual server, the hosting component of AWS. We also utilize auto scaling groups to help us scale up or down dynamically based on specific metrics, and I'll talk about some of those in a few. We utilize CloudWatch, which is where all of the metrics, the key metrics that are important to us, are stored. And Simple Queuing Service is one of the messaging components in AWS that allows the various services of AWS to coordinate tasks chronologically between themselves. And then SNS, which is the Simple Notification Service, allows us to proactively notify our staff of any sort of issues via email, SMS, and so forth. So with EC2, how many, before I actually dig in further here, how many of you are familiar with AWS and EC2? Okay, that's awesome. So now I have an idea of the audience and your experience there. So with EC2, well, when we first launched, actually, we were at the NAP in downtown Miami. We're based out of Miami, Florida, by the way. And we had physical servers at the NAP. We ran into some issues. It was just a hassle to kind of go back and forth physically or even interact with the remote hand service at the NAP. So we explored options for infrastructure as a service, and this is 2012, which Amazon had already been out, AWS had already been in existence for roughly 6 years at that point. So we explored Rackspace, we looked at some of the stuff Google Compute Cloud was doing, and we decided on AWS because, as many of you guys know, just the feature set was comparable. There was really no other competitor that allowed, that provided all of those features that AWS did. We migrated over, and initially we built a CentOS-based environment. So we standardized on CentOS 6, and over time we started running into issues. Performance issues of various sorts. However, we weren't able to get into specific configurations because we were utilizing the CentOS image, such as some of the network configuration options. It just didn't allow you to get to that level in AWS utilizing a non-Amazon based image, or AMI. So after looking into what distro was really the best for us, we decided to utilize Amazon Linux AMI because it's obviously supported by Amazon. They ensure that the updates are always available. They do give you a lot more control, such as some of the ftool commands. If you look at some of the options that are configurable for general segmentation, offloading, and TCP segmentation, and those items, a non-Amazon Linux AMI won't allow you to configure that. So we standardize our OS to Amazon Linux. Additionally, with the Amazon Linux AMI, they do provide you with, the APIs and a lot of the useful tools of AWS as part of that image. So everything is there out of the box, as opposed to a non-Amazon AMI where you'd have to set up and install the API and so forth on your own. So that was the very first thing that we realized, is to standardize on this distribution. As a startup, obviously we had very limited resources at the time, so we used shared resources, shared tenancy rather, for the instances, which as we grew started to reveal why they were shared and shouldn't be used for VoIP applications. So we migrated to dedicated instances. So now we are on Amazon Linux AMI, we're running dedicated instances, but we also had to switch the virtualization type from power virtualization to the hardware virtualization. You guys can do your independent research here, but PVs were initially the recommended virtualization method by Amazon until they made a lot of performance improvements and a few other items. And eventually, AWS recommended most instances or all instances to utilize the hardware virtualization method because it just proved over time to be a lot more reliable in terms of performance and stability. So We were initially on PVs and migrated over, and I'll spare you the details of the benefits there, but some of the ones that stood out to us was the fact that the VM wasn't aware of the shared processing time that it had with other machines. It was literally, it thinks that it's running on the host as closest to the bare metal as possible. And we noticed the difference in call quality just from these minor changes that we were implementing. So once we sort of mastered or fine-tuned the operating system layer and its configurations, we then went up to the next layer, which is the application services, right? So of course your base instance needs asterisk on it, but we also utilize fail to ban for monitoring the security log and looking for brute force login attempts and a few other items that may hit your servers. And fail to ban is a pretty solid tool. It allows you to listen and look for those things retroactively, however, which is the only downside to it. It isn't a real-time monitoring tool, again, because it's logging this information to a file, reading this information from the asterisk log files, as opposed to monitoring real time. However, it is very useful in knowing whether there's individuals trying to hack into your asterisk boxes. We also configured New Relic on the base image so that it's constantly reporting various items to our New Relic service. And then performance metrics. Now, this is key because some of the items that you're going to need later on to build out a really scalable telephony layer in Amazon depend on a lot of these metrics. The key items that needs to be pushed from your base image to Amazon's CloudWatch service is the load average in 1, 5, and 15-minute intervals. You also need to report on memory utilization, CPU, disk, and very importantly, current channel utilization of your asterisk machines. And CloudWatch allows you to create custom metrics for pretty much anything that you want. So you'd have to create your own scripting applications that will read these metrics and push them to the custom CloudWatch, essentially variables that you created. But they become extremely handy later on. So memory utilization, CPU, disk, and your asterisk channel utilization. Depending on your specific scenarios, obviously there's other asterisk-based components or triggers that you may want to report, but those were the ones that were important for us. So again, at this point, just to really recap, the operating system was standardized. We had some basic application services and configured them based on what we needed for future services. And then we looked at the network configuration, and this is where I mentioned with non-Amazon Linux AMI images that you're very limited in what you could tweak. So we tried various forms of optimizing these, from the Scalable, again, the TSO, GSO, offloading and turning, transaction receive and sending off and on. And the best quality settings that we found was in disabling the transaction offload for the NIC configuration. This is just done via ethtool, which I'm sure a lot of you are familiar with. So we disabled the TX offload and GSO utilizing ethtool. And in just with those two items, again, we noticed that it helped increase the quality of the calls from an Asterisk server running in AWS. Once we configured ethtool, we looked at some kernel tuning settings. So we made sure that all of the ports that are available for use were available to us. So we configured the local port range setting in syscontrol. We also, from a kernel perspective, looked at the backlog configuration, right? Because what we ran into over time was clients getting disconnected or timeouts and so forth, and found that it was due to the SYN configuration of our servers. At times, we'd see in the logs that there's a possible SYN flood attack, right? And it wasn't a SYN flood attack whatsoever, but because of the influx of clients accessing the specific server simultaneously, it caused Asterisk to think or the kernel to think that it was under attack. So the way that some of the items that we tweaked to address that was the max SYN backlog configuration. We found a pretty high number that allowed us to continue to accept requests without denying the next client that comes on. Because once you're flagged as having a SYN flood attack, the OS isn't receiving any additional connections, right? It's just dropping them. So by increasing the max SYN backlog, it allowed us to continue to accept these requests without any adverse impact from the client experience perspective. But we also had to tweak the SO-MaxCon, which is a socket, the default number of backlog or requests that you can accept to the listen method for your sockets. And these are kernel level settings that that must be tweaked, but each application obviously can override these settings, right? So we wanted to make sure that from the operating system's perspective, we were setting these max limits, but within the individual applications, we'd customize it to what we wanted and what we thought was best. One of the things that we also ran into this was several years ago with, I believe it was Asterisk 11, was that in the TCP TLS file, when it was accepting a socket, there was a fixed number for the backlog, which was 10, right? And that caused a lot of issues for us. So we needed to update the code there to make sure that Asterisk would read the option, the max files option from the asterisk.conf and pass that to the method as opposed to being fixed in the actual code. Because it gives you a lot more flexibility over your max file settings. And then we enabled TCP SYN cookies, which essentially allowed us to, it helped protect us from SYN flooding. And lastly, again, these are kernel level settings, so we increased the file max for the OS so that the application layer, whether it's Asterisk or any other, could set its own max open file settings and wouldn't be limited by the OS. Some other configuration items that are important, is to set a boot script, essentially just a blank template of a boot script, so that your image will be configured to launch a specific script from an NFS share or another shared location upon launch, right? So in the event that some unforeseen issue comes up or requirement comes up in the future, you could easily just update that script without having to rebuild your AMIs and do other things. It'll just pick it up upon boot, right? Depending on the load of the servers and the roles, a lot of people use use servers with shared roles and not dedicated. So you could have a asterisk box that's also running a web server and a few other things. And the OS you may run into out of memory issues, right? And by default, the OS is going to kill whatever process it thinks is the best to preserve, this performance on the system, and that includes your asterisk instance. So there's an out-of-memory adjustment that you can configure to tell the OS, hey, if there's any sort of performance issues or you think you got to kill a process because of potential out-of-memory issues, make sure it's not asterisk. And that's what the OM adjustment allows you to do. And then, you change your default ports to whatever is needed for your organization. And at that point, you have a base image upon which all of your future images could be derived. So once this is created, you create an actual AMI from it. And then you'd need to set up a simple queue service entry. And again, that allows you to just send messages between different components of AWS, specifically between the auto-scaling group for this purpose, between the auto-scaling group and your custom scripts, right? So with the simple queuing service, once that's created, you'd need a script that listens for life cycle actions in your auto-scaling group. And that's a component of the auto-scaling group feature in AWS. It essentially says, if I'm adding a new server to this group, this life cycle hook is a notification to external actors so that they can act upon it or do something before the auto-scaling group proceeds, right? So in this case, you'd want a life cycle, in this case, you'd want to make sure that your script reads the life cycle state of all instances. And this will come together in the next slide. But you want to read the life cycle state of your instance, right, in the script. And if the state is terminating, right, that means Amazon is telling you, hey, I'm about to turn this server off and shut it down because I need to scale down based on your configuration, so what you told me to do, right? So before I terminate the server, here's a notification that I'm going to do so. So you let me know whether or not I should proceed. And that property is stored in the lifecycle state. So your script goes through your instances, reads the lifecycle state. If it's terminating, wait. Then it needs to go to CloudWatch and read one of the metrics that I told you would be important later on, which is the total number of active channels, because you don't want to terminate a server and there's active calls and activity on the server, right? So your script needs to go to CloudWatch and read the number of channels that are currently on this machine that Amazon Autoscaling thinks it needs to terminate because it's underutilized. And if there are channels still in use, you tell the auto-scaling group you need more time, right? And you do that utilizing the record life cycle action heartbeat, which is the very last SQS entry here at the bottom, right? So you extend the time if there are still active channels on this server. If there isn't, then you tell it to proceed. which you do by calling the Complete Lifecycle Action API in AWS. So essentially, again, what you're doing is you're just creating a small script that goes through your instances that are being terminated potentially, or to be terminated by AWS, and you're making sure there aren't any active calls before you do that. And if there is, you tell Amazon you need more time, and it just remains in that state until you essentially release it. So that's what the SQS, this is how the SQS service plays into the overall scalability component here. Now, remember the base image is the AMI that I discussed earlier. So that has asterisk and it has filter bin, it has all these services running on it in order for you to create auto-scaling groups. And AWS allows you to set up your base configuration for your servers. So you select your AMI that you created in the beginning, and then you can set the amount of memory and CPU and so forth that you'd like your instances to have, and create this launch configuration. In the launch configuration, it's just a simple wizard. You go through and select these items. But the key thing to pay attention to is your security groups, right? Because you want to make sure that the ports that you customize are allowed, and you know their IP restrictions and so forth, at least on the AWS level, before you create your launch configuration. Because once it's created, every single instance that the auto-scaling group launches is going to utilize the exact same setting for each one of them. And in the auto-scaling group, this is where you create your scaling policies. So you can create a scaling policy that says, again, referencing the performance metrics that you're pushing from your base image scripting, that says if the 1 minute load average is X, right, do Y. So add more instances, add one more instance or 5 more instances to the farm. So as each active server that you have running based on this image, remember there's a script that's pushing all of this stuff to CloudWatch. And you can utilize CloudWatch to create these aggregate metrics that says every server in this auto-scaling group, what is the average load, 1 minute load average across all servers, or the 5 minute? Or what is the average CPU utilization or memory? So CloudWatch allows you to create aggregate summaries of these metrics, right? So with your scaling policies, you don't want to look at a specific server. You want to look at all of the servers that are in the farm and the average utilization of those servers. And if that average is above whatever your threshold may be for your company, then you tell it to scale up to n number of instances. And the inverse is true, right? So if the load average over the course of 1 minute intervals is at a certain level, then you scale down one instance, right? And there's moments of cooling down in between that you can configure, because it could get extremely sensitive. So for every situation, I just recommend that you find the cool down period that works for you, and that essentially is, if I'm scaling up, so if the system determines that it needs to add 5 more instances automatically, it's going to launch them, how long should it wait before triggering this again, right? So that's the cool down period that you've got to be aware of. And then again, the lifecycle hooks are created in the auto-scaling group APIs, and that's where you essentially say, once you create your auto-scaling group, that for the lifecycle transition called terminating, right? So the instance is terminating. and I have it listed here, EC2_instance terminating. I'd like to notify something, and that something is an SQS resource, which you specify. So you'd create that SQS queue that you created earlier. This is where you would connect the two, right? So now your server scales up, it does its thing, it finds that there's way too many instances running, it needs to scale down. Before it scales down, that instance state is going to change to EC2 terminating, which is going to trigger the SQS message. Remember, you have the script running from earlier so that it's listening for these messages. It sees that the instance is in the process of being terminated. It checks the CloudWatch total channels for that specific instance and finds that there aren't any active channels on that instance. So then it communicates back through SQS so that the auto-scaling group would be told to continue with the termination. And of course, there are a few other protections you want to put in place, like making sure that there aren't any future connections being established to the server. So if an instance is in that instance terminating state, whatever mechanism or in whatever capacity use case you utilize an asterisk, you got to make sure that it's not accepting any new channels, that those are being directed to other servers in your farm. And then lastly, again, you just want to set up some notification services using SNS so that you're notified via email, SMS, or any sort of other webhooks or APIs that you may have in place that performs custom tasks, and connect it all together. Connect it to your ASG, to your SQS, your EC2 instances, so that you're notified in the event that something goes awry. Okay, so again, this is really the beauty of how far we've come. You know, again, I've worked with Aspect. I've had hands-on experience setting up their DSPs, and we did a lot of programming with Asterisk and Bione back in the day, and so many others, and to see how AWS has really allowed us to focus on not hardware, but just solving this specific business problem that we're trying to address. It was just really amazing. So those are the core items for us. I mean, there are, again, a few other things. Every use case is different, but at the very foundation of scaling Asterisk servers in AWS, these are some of the critical items that you'd want to consider. Call quality, so fine-tune the network settings, the operating system settings. Look at any limitations that may be in your environment, and create your images based on that. It's just amazing, again, what we're able to do with AWS and Asterisk. So, and with that being said, that really concludes what I wanted to share with you guys. And at this point, I'd like to leave the floor open for questioning.
All right. Does anyone have a question? Just raise your hand. I will bring the microphone to you. We have a question right here.
What's your experience been with overall reliability of AWS, and were there any particular things that you did to maximize the results that you're getting aside from what you spoke about here today? In other words, do you have separate regions set up so if there's a problem, things fail over?
Yeah, absolutely. The reliability for us, it's been, we've had 4 nines of availability. We initially launched in the Virginia region because we started in Miami, Florida. A lot of the clients were East Coast clients. To avoid any latency issues and so forth, we wanted the region nearest our clients. But as we grew and started, getting clients all over the country and then eventually all over the world, we needed to expand to Oregon and also Frankfurt. And you do want to make sure that, which is also part of the configuration settings here, that when instances are launching up, they're not launching in the same availability zones. It's balanced across the board. There's settings that allows you to do that. In API, you can specify what availability zones you want an instance to launch in. But we make sure that instances are spread across different availability zones within that region. But each region is independent of each other in that regard. But we do have, cold standby instances that's ready to turn up, essentially, should we have an issue in a specific region. But outside of the S3 outages that we've experienced twice with AWS, the EC2 service has been pretty solid. Over the last 4 years or so, we've been using it.
Hi, hello. I was wondering about the scale down matter of this kind of scenario, and I myself have a lot of problems, like not directing calls to the asterisks that are in the farm. I see that you guys solved this with the Amazon infrastructure. Is that correct? Can you explain a little bit more about this? How you stop directing calls to a server so you can scale him down?
Well, so first you've got to look at whatever component of yours that's responsible for placing the calls, right? And I'm sure that you have some sort of script running to do that. So outside of the infrastructure side, within your applications themselves, there are also updates that you've got to make. So in your specific case, you got to make sure that the moment an instance it transitions to the instance terminating state, that you flag that somewhere, whether it's in your database or where you have database of server entries or whatever the case may be. But you need to flag that server so that any other applications that you have could look at that flag before they continue to send any calls through that machine.
Hi. Actually, I have two questions. First is, what is the purpose of News Relic?
What's the purpose of?
New Relic.
New Relic?
Yeah.
We use it for monitoring quite a bit, so server monitoring.
Okay.
It proactively, so with New Relic, it proactively pushes, acquires statistics on your servers, right? And then it pushes it back to the New Relic Cloud application monitoring service. So your guys can go in and kind of look at all of the different servers that are running. Remember, with this scalable infrastructure, you could have, that's like this, you could have anywhere from 10 to hundreds of servers running at the same time. So it's not, you need a tool to monitor all of those servers, right? And New Relic allows us to, it's one of the tools, but it allows us to look at all of the servers that we have and identify which ones may have potential disk space issues coming up because there's tons of recordings or whatever the case may be. And it's just one view that does that. But the other benefit to it is New Relic itself integrates with other other web services like PagerDuty. So if a disk if a drive is at, 80% utilization, in New Relic you can tell it to trigger an alert, right, at that threshold. PagerDuty, on the other hand, reads your New Relic triggers. So the moment a disk becomes 80% utilization, PagerDuty realizes that and then sends all of your guys text messages and emails and saying, hey, this server, this IP has disk space, potential disk space
Using
issues.
SNS, I think. Using SNS.
With PagerDuty, I'm not sure what they use,
okay.
but they would send you text messages, SMS messages, and other and emails to notify you.
Okay. My second question is how do you manage this open files max? I mean, did you change any core code in Asterisk to manage this open files max?
No, what we changed it in the kernel configuration. So in syscontrol, we modified the fs file dash max so that we won't be limited on the OS side. But then we used ulimit to set the actual application layer setting, which we matched to meet what we set in the kernel. So those are the two locations where we made the changes to support that.
Since going dedicated instance and doing all your tuning settings and hardware virtualization, have you had any sort of timing problems, anything like that? And how have Amazon sort of helped out with those kinds of things?
We didn't. We didn't really experience any timing issues. Whenever we've had to rebuild the base image, it was more to add functionality that we didn't anticipate, that we couldn't add to this empty script, right? So it wasn't a scripting issue. But we never really ran into any timing issues. Once all of your servers are running NTP date and they're all synchronized.
So I meant from like an RTP perspective, have you ever had any sort of jitter?
Okay.
Any jitter problems, anything like that, the hardware clock, obviously, that you depend on, causing the packets to obviously skew and things like that?
Yeah, we did. And that's the settings that I kind of described here. Those are the settings that we found work the best, right? Because we did run into a lot of call quality issues, and that's why we played around with almost every setting in the kernel's configuration for syscontrol. By turning off the transaction and GSO, it resulted in the best quality for us.
All right, any additional questions? All right, well, let's give a huge round of applause to Mr. Marlon Williams. Thank you very much.